Hello everyone, my name is Zhang and you also can call me Heather. I'm from North Dakota State University. So today is my first time to do the presentation in front of so many international people. So I'm very happy and nervous. So my topic today is about the machine learning based UAS application in precision agriculture. And today I'm going to focus on two parts. One is about the introduction about UAV platform and applications in our research team. And the other part, I'm going to move on the machine learning research, what we are doing right now. So these are the UAV platforms in our research team, and we divide them into two categories. One is the quadcopter, and the other one is the fixed wings. For the quadcopter, the flight time is about 15 minutes to 20 minutes, and the acres per flight is about 20 acres, and the speed is a little bit slower, 10 to 20 miles per hour. And for the fixed ones, we usually call that large-size UAVs. So it can fly about 1 hour to 1.5 hours per flight, and the acres is about 640 acres per flight. The speed is much faster than the quadcopter, so it's about 30 to 45 miles per hour. So because of their different features, though they can be used in different applications. The quadcopter, we can use them for the crop scouting and the smaller size field mapping. The fixed ones, the fixed wing UAVs, we can use them for the large field mapping. And we also can put a lot of sensors on the UAVs. We can put like the thermal camera, or the hyperspectral camera, or multispectral camera. We even can put a LiDAR on the UAVs to get the 3D data from the field. So our UAVs can use in different kinds of application in agriculture. We can use that in the crop applications and the livestock applications. For the crop application, we can monitor the crop status. Also, we can get the nutrition status of the crop and the disease or insect damage from the crop. We also can analyze the water stress or the crop maturity. In the livestock application, we can monitor the animal movements, animal behaviors, and we also can capture some temperatures or some other data from the livestock field. So those pictures are used in the crop applications and the livestock applications. And now I'm going to move on the machine learning research, what we are doing right now. So the first one is the estimation of animal count using UAS-based color image. In some smaller size beef cattle barn, we can use the smaller size UAVs to capture the color image of the field. And we also can using the color features to identify the animals in the pictures, so we can get the number of the animals. But in some occasions, we like in the large size feedlots, we cannot use the smaller size UAVs because the flight time is limited and it's kind of time consuming in the large field. So we choose the large size UAVs like the fixed wings UAVs. And also in the large size UAVs, in the large size feedlots, we cannot identify the animals, just use the color features. So we need more features. So we mount the multispectral sensor on the large UAV. And those three pictures are the multispectral image. And it's very hard to see the animals on those, like the big size feedlot. So we need some more features about like the texture features about the animals. And I'm using the grade level co-occurrence matrix to extract the features about the animals. And then I input all the features into the SVM classifier, and then I can identify the animals in the picture. And the next project is about the identification of herbicide-resistant weeds using UAS-based thermal image. So in this project, we have two objectives. The first one, we need to identify the resistant weeds from the susceptible ones. And the second one, we need to decide when is the best time to identify the weeds. So the resistant weeds and the susceptible weeds shows different canopy temperature in the thermal image. So we can see the thermal signature from that graph. And so we are just using the thermal signature to identify the resistant weeds. Here I use a stepwise regression to select the best. I cannot say it's the best. I just want to say it's the significant features from all those features. We collect all the temperature features every single hour after the herbicide application. So those 4 features are the selected ones we use the stepwise. And after that, we also can build the model from using those features. So all about is about our research and UAV platform in our research team. And I want to introduce my research team leader. Dr. Srikala Bajwa is also our department head, and John Nowosky is our extension specialist. We did a lot of research based on the UAVs, and we are really looking forward to more collaborations with all the excellent facility and the university. Thank you.
So when you were classifying the water hemp as sensitive or resistant to the herbicide, you did a temperature measurement, and that's what gave you your classification. Yeah. How did you know which ones were resistant and susceptible, or is this after you've already sprayed with the herbicide?
Okay, so we collaborate the thermal temperatures from those, and we have the training data set. So in the training data set, we know which one is the susceptible ones and which one is the resistant ones.
How do you know that? How do you know which one?
That's a pre-knowledge like that. We use that for training the classifier. After the training the classifier, and then we can predict or identify them.
Okay, thanks.
Thank you.